Let's look at this problem called flip string to monotone increasing. A binary string is monotone increasing if it consists of some number of zeros followed by some number of ones. You are given a binary string S. You can flip Si changing it from 0 to 1 or from 1 to 0. Return the minimum number of flips to make string S monotone increasing. Okay. We look at this example. In this case, if you flip this 0 to 1, it will become all zeros followed by all ones, and that's the minimum number of flips that we will really need. In this case, there are two options. Either we flip both of these zeros to ones. In that case, we'll get 0 followed by all ones, which is monotone increasing. Or we can flip this 1 to 0 so that we get 0, 0, 0, 1, 1, and this is 0 to 1, right? So this 1 to 0 and this 0 to 1. So we get 0, 0, 0, 1, 1, 1. So in two flips, we can get two different ways to make it monotonic increasing. So the minimum flips are 2. In this case, we can flip both of these ones to 0, and that will be the minimum number of flips. So how can we solve this problem? Well, essentially, if a string ending at index I is monotonic increasing, then a string, it is possible only if the string ending at index I minus 1 is monotonic increasing, or rather any substring if you take within the string of a monotonic increasing string has to be increasing. We go from left to right, we'll ensure the I minus 1 string till I minus 1 is monotonic increasing, and then we'll figure out whether or not we have to do a flip at I. Now, a monotonic increasing string, obviously there are two options. Either it will be all zeros or it will be some zeros followed by some ones, right? Or it will be all ones, all three cases. But ultimately, the monotonically increasing string will either end at 0 or it will end at 1. These are the only two options, right? So let's define those two things, those two states, right? So either you want to be able to make some flips and you have to reach a monotonically ending string, monotonic increasing string ending with 0, or so this I will say is the minimum flips needed to make string monotonic increasing ending with 0, right? And similarly, let's say other option is this is flips 1, minimum number of flips needed to make string monotonic increasing ending with 1. So these are the two different options, right? So now if I'm at character C, let's say, so if I'm at index I, if I'm at index I, and at index I, my character, there are two options, right? Either it can be 0 or it can be 1. So let's figure out this flips 0, flips 1 for both scenarios. So flips 0 of I, right? So if I want to have the string to be a monotonic string ending with 0, well, then this character is already 0, all good. Then I need to ensure that I minus 1 is also a monotonic string ending with 0. So that means whatever different flips I had to do to make the string till I minus 1 monotonic increasing, that's the only flips I need, right? Another is, what about I want the string to end with 1 instead? Well, if you want it to end with 1, your current character is 0. So you have to first change that to 1, right? So that's obvious. And what about I minus 1? Well, I minus 1, is there a limit? Is there a restriction on the I minus 1 character? No, if you are 1, then your previous character can be either 0 or 1. But you have to ensure that it's the entire I minus 1 string is a monotonic string, right? So it can end with either 0 or 1, does not matter. But it has to be monotonic increasing. So we'll take the minimum of the number of flips to make. So math.min will take either it's a monotonic string ending with 0, so all zeros, and this index becomes 1, which is completely fine, or it is at some point it changed to 1. I don't know at which point, but at some point it changed to 1. But it's a monotonic increasing string, 0, 0, 0, then some 1, 1, 1, and now this guy is a 0 and we are flipping it to 1, right? So that's flips of I1. So these are the two different scenarios. What about this character was 1? Well, then, if you wanted it to be a monotonic string ending with 0, you'll have to flip uh, the character, because this character is 1, you have to flip it to make it 0. And what about all the previous I minus 1? Well, if you are 0, then there is a restriction that the previous guy also has to be 0 only, right? Or instead, in fact, all of the previous guys have to be 0. So we take flips of I minus 1. And what about if you wanted this to be a monotonic string ending with 1? Ending with 1, well, this character is already 1. So the only requirement is the previous I minus one should be a monotonic string. So we take the minimum of basically this, right? Uh, Whichever path made the I minus one of the string a monotonic string, either ending with zero or ending with one does not matter. So that's our entire logic. And at the end, we'll return a minimum of flips zero and flips one. Now we are looking at it as an array, but if you really look at it, it only depends upon the previous values of flip 0 and flips 1. So maybe we can do that by just using some constant variables, like just some variables instead of an actual array. So let's try and code this up. So we are taking flips of 0 as 0 initially, and no flips done, and flips of 1 as 1. Now we go for each character in as dot to char array. So we go flips of 0. Okay, so now we're saying it depends upon the character, right? So if the character is 0 or if it's 1, right? If the character is 0, then we're saying what about flips of 0? It does not change. Whatever was the previous value, right? Then it's good. What about flips of 1? 1 plus the minimum of either two. So flips 1 is the only guy that changed. So we say flips of 1 equals to math.min flips 0 flips 1, and we had to flip from 0 to 1. So 1 plus whatever minimum flips were needed to make the previous string or string till I minus 1 as a monotonic increasing one, right? And flipping this. And if it is 1, then flips of 0 increases by 1, right? So flips of 0 is 1 plus this. But flips of 1 also depends upon flips of 0. So if you change this, it becomes problematic. So maybe do this first, right? So we can do that first. So we do flips of 1. Again, flips of 1 is, it was 1, it is already 1, all good. All you need is the minimum flips that you needed to make the previous string a monotonic string, and which could be ending with either 0 or 1, does not matter. So that's our entire logic, right? And at the end, we just return math.min flips 0 and flips 1, right? Finally, minimum number of flips to make the string either end with 0 or end with 1 and be monotonic. So that's our entire logic. Let's submit, and it works. All right.